Problem number 1. The square root of 125n. Now obviously 125 is not a square root, so we want to find the prime factorizations of 125. Right off the bat, I notice that this value ends in a 5, so it's definitely going to be divisible by 5. If I divide 125 by 5, I get the square root of 5 times 25 times n. Now we should notice that 25 is a perfect square, and since 25 is a perfect square, it consists of a multiples of 5 times 5, and if I want to rewrite it just for the sake of seeing it, that would be 5 times 5 times 5 times n. And now my pair of twins would be the 5 and 5. And when you take the square root of 25, that drops out 5. So one of those pairs disappears and comes out front. That leaves me inside the radical the 5 and the n. So my solution, 5 root 5n. Let's look at problem number 4. Problem number 4 is the square root of 512 m to the third power. Now, we're looking for prime factorizations, so I'm going to take 512 and divide it by 2. So that will give me the square root of 2 times 256 times m to the third power. Now I see right away that my 256 is a perfect square. That's 16. So if I take the square root of 256, that's going to pop a 16 in front of my radical. And that will leave left inside the square root 2 m to the third power. Now so far we haven't done anything with the variable. M to the third power is the same thing as 16 times 2 to the m times m times m power. Not power, sorry. M times m times m. So again, I see a pair of twins. Anytime we have a pair of twins, one of them's going to cancel out, the other's going to come out front. So that's going to leave me with 16m. Inside the radicand, I have 2, and I have m all by themselves. 16m root 2m. Number 13. Square root of 16, u to the fourth, v to the third. Now again, I'm going to start this problem by finding my prime factorization, but I notice right away that 16 is a perfect square. So the square root of 16 is going to kick out a 4 because that's the same as saying 4 times 4. Where one of my twins gets marked out, the other gets brought to the front of the radicand. So I have 4 root u to the 4, v to the third. Now we need to remember that 4 root u4 is the same thing as saying 4 times u to the 4th raised to the 1/2 times v to the 3rd raised to the 1/2. So we can apply our power to power rules here. 4 times 1/2 would be 4/2, which is the same thing as 2. So that's going to simplify down to 4 times u squared. Now, v raised to the 3rd raised to the 1/2. Again, we can apply our power to power rule, and we would get 3/2. Well, 3/2 is the same thing as v squared times v. If I take the square root of v squared, that's going to simplify to v, so it will come out of the radicand, and we're left with 4u squared times v times the root of v. Let's see, that would be 2 odds and 1 even. Let's go for one more even. How about number 28? 28 is negative 2 square root of 48a to the 3rd, b to the 4th, c squared. Well, I'm going to start with my factorizations of my integer. Negative 2 times the root of 48 is divisible by 2. That would be 2 times 24. 24 is also divisible by 2. That would leave me with 12. 12 is also divisible by 2. That would leave me with 6. 6 is also divisible by 2. That would leave me with 3. Now just to check to make sure we did all this right, 2 times 2 is 4. Times 2 is 8, times 2 is 16, times 3 is 48. So we know we did our factorization correctly. Gonna need a little bit longer of a bar there. A to the 3rd power, b to the 4th power, c squared. Now I see right away I have one pair of 2's. I have a second pair of 2's, which means both of those are gonna knock one off and kick forward. So I'll have negative 2 times 2 times 2. I'll leave myself just a little bit of room for the variables when I start to deal with those, because we're going to do this a little more auditorially. I see that I have a 3 left inside the radicand. My a to the 3rd power, if I take the root of that, that means I'm going to divide the 3 by 2. 3 divided by 2 is 1, so that will leave me a to the 1st power with a remainder of 1a, which will stay inside the radicand. B to the 4th power, 4 divided by 2 is 2, so that will leave me with b squared. C to the 2nd power, 2 divided by 2 is 1, so that leaves me c all by itself. One final step to clean up. Negative 2 times 2 is negative 4. Negative 4 times 2 is negative 8. A, b squared, c, root of 3a. And if you follow those patterns for each of the rest of the problems, you should be in pretty good shape for completing your homework tonight.